Just 30 days of overeating can trigger profound changes to the immune and cardiovascular system, leading to early signs of inflammation and heart disease, new research has shown. The surprise finding was made by a team from Stanford University in the US, which found that weight gain of only 2.8 kilograms was enough to bring about molecular level changes in people with a body mass index (BMI) that classified them as overweight or moderately obese. Michael Snyder and his colleagues profiled the blood and microbiomes of 23 people with a BMI between 25 and 35. Some of these participants had normal sensitivity to insulin, while others were insulin resistant, which is an early sign of type 2 diabetes. The researchers analyzed participants' microbiomes and genomes, as well as their gene activity, protein levels, and the production of molecules associated with metabolism and inflammation. In the end, we literally made billions of measurements, says Snyder. The insulin-resistant group differed significantly from the metabolically healthy insulin-sensitive group, particularly in their microbial populations and metabolite levels. Notably, the insulin-resistant group had increased activity in pathways involved in inflammatory responses. When all participants were given a high-calorie diet for 30 days, causing them to gain an average of 2.8 kilograms, their molecular profiles changed dramatically. In both groups, expression of genes involved in lipid metabolism and inflammation increased, suggesting even modest weight gain triggers a stress response. Particularly concerning was a pronounced rise in the expression of genes associated with cardiomyopathy, a disease that diminishes the heart's ability to pump blood. That was quite surprising, says Snyder. I didn't expect 30 days of overeating to change the whole heart pathway. Microbial profiles changed, too. For example, the insulin-sensitive group experienced an increase in levels of the bacteria Akkermansia muciniphila, which helps protect against insulin resistance. These findings, published in Cell Systems, provide new insight into the gradual molecular and cellular changes through which obesity contributes to chronic inflammatory conditions like type 2 diabetes and heart disease. This all fits with how we think of the human body. It's a whole system, not just a few isolated components, so there are system-wide changes when people gain weight, Snyder says. The good news was that when participants lost the weight, their profiles mostly returned to original levels. A few changes lingered though, suggesting some effects could be longer lasting.